Mabuhay o panayaw. Hello everybody, today we will be tackling about patterns and diagrams, Rosette and Frieze pattern. But before we move on to these type of patterns, let's first review what is pattern. So, in mathematics, pattern is a repeated arrangement of numbers, colors, shapes, and so on. So, after our first glimpse of the title might be, what is Rosette? Or what is the definition behind it? Well, in architecture, it is a type of round flower-like design. So let's have a full definition of Rosette pattern. So Rosette pattern are symmetrical designs that can be found in nature and art, characterized by their radial symmetry around a central point. So Rosette pattern can exhibit two main types of symmetries, which is the cyclic and the dihedral symmetry. So, what is cyclic symmetry? So, cyclic symmetry is only rotational symmetry, meaning it looks the same after being rotated by a certain angles, but it lacks reflectional symmetry. First example of this is a pattern might repeat every 120 degrees, indicating a threefold rotational symmetry, denoted as Cn, where n is the number of repetitions. So for our next example, we have this picture. It is still a cyclic symmetry group since it can be rotated for angles of 120, 240, and 360 degrees and still remains in the original shape. So if we fold this picture into half, it still coincides with the other half because of the curve. So meaning it does not have reflectional symmetry. Next is third example. This picture still only has rotational symmetry because of the parallelograms cannot match after folding. There are a total of 7 assembled groups in this picture. Each contains some lines, dots, and a parallelogram. So I don't know if you can see it in the video, but there is a line in this pattern. So this pattern is denoted as C7. It has 7 symmetrical divisions. C, where C is the cyclic, and 7 is the symmetrical division. Next is we have the last Rosette. It is still a circular and classified as still C7, meaning it only has rotational symmetry. The curve of the lines prevent the image from having reflective symmetry. If reflected, the lines will be opposite to their original orientation. So if we still fold this picture into half, it will not be the same to their original orientation. Next is dihedral pattern. So what is dihedral patterns? Dihedral patterns possess both rotational and reflectional symmetries. Meaning, not only can they be rotated to look the same, but they can also be reflected across certain lines or mirror lines and still appear unchanged. So these patterns are denoted as Dn, where n represents the number of symmetrical divisions. We have this example. It is a square shape and has a rotational order of 5. It also has 5 mirror lines, which makes this figure part of the dihedral group. So it is B5 because it has 5 reflectional symmetry. 1, 2, 3, 4, 5. D is the dihedral. Next is we have this image. 120